This video is presented to you by www.testprepadda.com. Dear students, in this session of trigonometry, we will learn about domain, range, periodicity, and graphs for different trigonometric functions. Okay, so first of all, what is a domain? If I take y is equal to fx, y is a function of x, then this set of values of x for which this y is defined is called domain of this given function. So values of x for which fx is defined, that we say as domain. Now what is a range? Range, again, if I take y is equal to fx as a function, then set of values of y is called range of this given function. Means here values of y, range. Now I'll talk about periodicity of a function. Periodicity. If I write fx is equal to fx plus t, then fx is called a periodic function. Then fx is called a periodic function. Periodic function, and t will be called period of fx, but only if t is numerically least possible. Getting the idea? So t will be the period of fx if t is least. So this is about domain, range, and period. Now I'll talk about domain, range, period, and graph for different trigonometric functions. Dear students, now I'll take trigonometric function sine x. So if I write y is equal to sine x, y is equal to sine x. Consider a circle with unit radius. Although we have done this in the previous sessions of trigonometry, but I am repeating this for you. This is a circle with unit radius x minus x, y minus y. Let this as A, this as B, this as C, this as D. Since it is unit radius circle, the A coordinates will be 1, 0. B coordinates will be 0, 1. C coordinates will be minus 1, 0. And D coordinates will be 0, minus 1. Okay. Now, if you recall, we have defined sine x as sine x as, or better you say sine theta as, we have defined sine theta as the y coordinate. Y coordinate. Y coordinate. And if you check here, the maximum value is 1 and the minimum value is minus 1. So here this y coordinate lies between minus 1 and plus 1. So this sine theta lies between minus 1 and plus 1. So if I talk in terms of function y is equal to sine x, we can easily say that this is defined for all values of x. All values of x. X belongs to real number. So the domain will be what? Domain will be x, where x belongs to real number. Okay. Now, what will be the range? Range we have already predicted. Since this lies between minus 1 and plus 1, the range will be minus 1 to 1, both inclusive. Got the idea? So this way we get domain and range. Now, if you check carefully, when 0 radian, sine 0 is 0. Sine pi by 2 is 1. Sine pi is 0. Sine 3 pi by 2 is minus 1. And then sine 2 pi is 0. So you can see the value is repeating after what? 2 pi. So we can say this fx is equal to sine x is equal to sine 2 pi plus x. In general, if I write, it will be sine 2n pi plus x. The least value is 2 pi. So here the period for sine x will be 2 pi. Okay. Now, we will talk about the graph. Graph of y is equal to sine x. Now, if you go back and check this unit circle, here you can easily say as angle increases from 0 to pi by 2, the value increases, since it's a y coordinate, the value increases from 0 to 1, and then from pi by 2 to pi, the value from 1 to it becomes 0, means decreases. Now from pi to 3 pi by 2, it becomes 0 to minus 1, further decreases. And then from 3 pi by 2 to 2 pi, it increases from minus 1 to 0. And this will help us in getting the graph. If I take this as y-axis, this as x-axis, and here if I take 1, here if I take minus 1, and this is 0 radian. Now here if I take pi by 2, here if I take pi, here if I take 3 pi by 2, here if I take 2 pi. Pi by 2, the value is maximum. Pi, the value is 0. At 0 also it is 0. 3 pi by 2, the value is minimum. 2 pi, the value is 0. So from 0 to pi by 2, it is increasing. From pi by 2 to pi, it is decreasing. Then from pi to 3 by 2, it is further decreasing to minimum. And then from 3 pi by 2 to 2 pi, it is increasing. Okay, now if I draw this left hand side also, it will be minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. So here it will be like this, 0, then maximum, and then 0. Okay, so you can see the graph is repeating. At what interval? 2 pi. After 2 pi, the graph is repeating. This is the graph of sin x. Now I'll talk about cos x, another trigonometric function. Y is equal to cos x. Again, in the similar manner, I'll take the unit circle. Again, the same way. Here it's very clear that cos theta is nothing but x coordinate. Please don't get confused. Here theta I'm taking angle. Here x is the angle. So both are not same here. This x and this x, they are different. Okay, here I'm just taking this unit circle for the reference. Otherwise, I'm writing function as y is equal to cos x. Now, x coordinate. Here it is 1. Here it is -1. Got the idea? So, it is defined for all values. So, if I say domain, then you will say it is defined for all values of x. All values of x. So domain, if I write, it will be x, where x belongs to R. Okay. Now range. You can see it is very much clear that cos theta lies between -1 and +1. So it will be -1 less than or equal to plus cos x less than or equal to +1. So the range will be -1 to +1, both inclusive. Okay. Now periodicity. Period. Here also if you check, cos 0 is 1. Then cos pi by 2 is 0. Then cos pi is -1. Then cos 3 pi by 2 is 0. Then cos 2 pi is 1. You can see now it's repeating. After what interval? 2 pi. So here we can write cos 2 pi plus x is equal to cos x. In general, we can write cos 2n pi plus x is equal to cos x. The least is 2 pi. So 2 pi will be considered as the period of cos x. Got it? Now here if I try to draw the graph +1 -1, take this as 0. Again pi by 2, pi, 3 pi by 2, 2 pi. And this side I can write minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay, this time cos 0 is 1, cos pi by 2 is 0, then cos pi is -1, then again 0, then maximum. So what will you do? The graph will move like this, and if I extend this side, it will move like this. Okay, so here also in the same manner you can see the graph repeats. The graph repeats after 2 pi of interval. So 2 pi is the period, and this is the graph of y is equal to cos x. Okay, now I'll talk about the graph, domain, range, and period for tan x. Y is equal to tan x, another trigonometric function. Here, since tan x is sin x upon cos x, the denominator has cos x and denominator cannot be 0. That is why this function is not defined for all those values of x where cos x is 0. Okay, and cos x will be 0 for what values of x? For what values of x cos x will be 0? 2n plus 1 pi by 2, where n is what? Integer. Got the idea? So x should not be equal to this. So what is the domain of this tan x? Domain will be a set of what? X, where x belongs to real numbers and x should not be equal to 2n plus 1 pi by 2, where n belongs to integer. Got it? Now range range is set of all real numbers, set of all real numbers. Okay, now important point, if you go and check the circle with the unit radius, here if I draw 1 0 0 1 minus 1 0 0 minus 1, tan x is actually y coordinate upon x coordinate. So tan x or tan theta, the variation in different quadrants will be, in the first quadrant it increases from 0 to infinity, from 0 to infinity, and in the second quadrant it again increases from minus infinity to 0 in the second quadrant. Now third quadrant it will be 0 to infinity. In the fourth quadrant it will be minus infinity to 0. Now if I draw this as the graph, then This has x-axis, this has x minus x, and y-axis, y minus y. This has 0, and then 0 to pi by 2, and then pi by 2, pi, then 3 pi by 2, and then 2 pi. And as we know, 0 to pi by 2, it increases from 0 to infinity. So you have to draw a vertical line here, and you have to show the graph going from 0 to infinity. It will become parallel to this line. Okay. Now, from pi by 2 to pi, from pi by 2 to pi, it is a minus infinity to 0. So again we will draw this. Minus infinity is here, minus infinity to 0. So the graph will go like this. Then in the third quadrant, it 0 to infinity. 0 to infinity means this. Now, in the fourth quadrant, minus infinity to 0. Minus infinity to 0. Okay. Now, if I extend this side, it is minus pi by 2, it is minus pi minus 3 pi by 2, and then minus 2 pi. So same diagram will come like this. Now like this, you can see every time the graph repeats itself after an interval of pi. So what conclusion you can draw from here is the period. The period of this graph will be what? Pi. Now recall, the period of sine was 2 pi, cos was 2 pi, but for tan, the period is coming as pi. Got the idea? So I can write tan pi plus x is equal to tan x. Got it? Okay. Now I will talk about the another trigonometric function cot x, which is the reciprocal of tan x. Cot x is the reciprocal of tan x. Here, cot x is cos x upon sin x. Since sin x is in the denominator, sin x should not be equal to 0. So x should not be equal to n pi. That is why the domain of this is set of what? X, such that x belongs to real number, and this x should not be equal to n pi, where n is integer. Got it? Now range similar to tan, range all real numbers, set of all real numbers. This is the range. Now I'll talk about the graph. I'll talk about the graph. Here, please note that the cortex in the first quadrant, it decreases from infinity to 0. In the second quadrant, it decreases from 0 to minus infinity. Third quadrant, it decreases from infinity to 0, and the fourth quadrant also, it decreases from 0 to minus infinity. Got it? And that can be observed from the unit circle. 1 0 0 1 minus 1 0 0 minus 1. Got it? So x-axis x minus x, y minus y, 0. Here pi by 2, pi, 3 pi by 2, 2 pi. This side if I go minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Now first quadrant decreases infinity to 0. So if I draw this, infinity to 0 means like this. Now from pi by 2 to pi, again from 0 to minus infinity. Same here, infinity to 0 and then 0 to. Now similarly you can extend graph this side, but the important point here is if you see the graph carefully, it repeats after an interval of pi. So here also the period of this function is what? Pi. The period is pi. Okay. Now I'll take the another function, and that is the sec x. Y is equal to sec x. Here sec x is equal to actually 1 upon cos x. It is reciprocal of cos x. If it is reciprocal of cos x is in the denominator. So cos x should not be equal to 0. And that is why x should not be equal to 2n plus 1 pi by 2, where n belongs to integers. Okay, so domain of this can be defined as set of x, where x belongs to R, and x should not be equal to 2n plus 1 pi by 2, where n belongs to integers. And if I talk about range, consider the same unit circle. Here we know 1 0, 0 1, minus 1 0, 0 minus 1. As you know, y is 1 upon cos x, and cos x is actually the x coordinate. Here the x coordinate is 1. Here the x coordinate is 0. So in the first quadrant, it increases from 1 to infinity. In the second quadrant, the initially it is 0. So here in the second quadrant, the variation will be it increases from minus infinity. It increases from minus infinity minus 1. Minus infinity to minus 1. In the third quadrant, it will decrease from minus 1 to minus infinity. In the fourth quadrant, it will decrease from infinity to minus 1. Now, if I convert this into graphs, it will be like this. Consider this as 1, this as minus 1. This as 0, pi by 2, pi, 3 pi by 2, 2 pi. Okay, so now in the first quadrant, it increases from 1 to infinity. It increases from 1 to infinity. So this way. Now the second quadrant, it says it increases from minus infinity, means from here minus infinity to minus 1. This is minus 1. So the graph will go like this. Now in the third quadrant, means pi to 3 pi by 2, it decreases from minus 1 to minus infinity. Means graph will come like this. This is the sharp point. Now, in the fourth quadrant, it decreases from infinity to 1. Infinity to actually it is 1. Here I have written minus 1. So it is infinity to 1. Okay. Now, if I extend this, the graph will look like this here. Okay. So we can extend here. Now, here the range can be defined. Range can be defined as a set of y. Y belongs to R and y greater than or equal to 1 or y less than or equal to minus 1. Getting the idea? This is the range for a sec x. And here the period is 2 pi. Here the period is 2 pi. Okay, now I'll talk about the graph domain range for cosec x, another function, which is equal to 1 upon sine x. 1 upon sine x. Now, as we did in the previous case, cos x was in the denominator. Here sin x is in the denominator. So sin x should not be equal to 0. So here y will not be defined. Whenever sin x is 0 means x n pi, where n belongs to integers. Got the idea? So, what domain we can write here? Set of x. X belongs to R and x should not be equal to n pi, where n belongs to integers. Now, when I talk about the range, before this, I'll tell you the variation in different quadrants. For cosec x, in the first quadrant, it decreases. It decreases from infinity to 1. In the second quadrant, it increases from 1 to infinity. In the third quadrant, it increases from minus infinity to minus 1. In the fourth quadrant, it decreases from minus 1 to minus infinity. This will help us in getting the graph. If I take this as 1, this as minus 1, now take this as 0, this as pi by 2, this as pi, then 3 pi by 2, then 2 pi. Now, in the first quadrant, it says decreases from infinity to 1. So, the graph will look like this. Okay, now in the second quadrant, increases from 1 to infinity. So, the graph will go like this. Then third quadrant, minus infinity to minus 1. Minus infinity to minus 1, it will look like this. Now, in the fourth quadrant, decreases from minus 1 to minus infinity. It will look like this. And you can extend this left hand side also. So, here the range range is defined by the set y belongs to R and y greater than or equal to 1 or y less than or equal to minus 1. Got it? Range is this. Now you can easily predict the period. What is the period here? Period is 2 pi. Got it? So here we discussed different graphs for different trigonometric functions. Okay, now dear students, in the next session of trigonometry, we will discuss questions related to all this theory. Okay, thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.